Okay, so I've just been watching this documentary about Space Shuttle. It's narrated by William Shatner, but then they go into the heat shield tiles on the Space Shuttle, which I haven't really thought about it too much in detail. But if you imagine the Space Shuttle is just basically an aeroplane, an aluminum shell, a plane, and then they stick these thermal heat tiles onto the outside with glue. And apparently the space shuttle had problems from the very get-go with these tiles falling off. I'll just read you this article. I just did a quick search, found this article, ABC News. I'll just read a couple of paragraphs, and then I've chopped the bits out of the documentary and just put them together, that you can watch after this. But I'll just read this quickly. Even before Columbia was first launched, it lost more than 2,000 of its tiles as it was being ferried to Florida on the back of an airplane in 1979. After a 2-year delay to fix the tiles, the Columbia was finally launched in 1981. Despite all of the work that was done during the delay, Columbia still lost 15 tiles during the blast-off. Now, what's the next one? And on almost every shuttle flight since, there has been some kind of problem with the tiles, although never in critical areas. Now, if you imagine the stresses and the strains that this space shuttle has to go through, they claim flying at 24,000 miles an hour, which is Mach 25, which is like 25 times faster than the speed of sound, and then the heat temperatures that it has to go through, so you're talking 3,000 degrees, they claim, re-entering the atmosphere, and these tiles are stuck on with glue. And I'm telling you now, there is no glue known to man that could deal with the temperature parameters and also the cooling down as well. But of course, in the documentary it just says, oh, NASA overcame this problem, but they don't explain how. They just found some magic NASA glue solved the problem, but I don't believe that's the case. So to me it looks like there's a problem with the space. I mean, can you imagine even one of those tiles coming off? How would this space shuttle operate in space and then come back through the atmosphere with those kinds of heat? Is just, yeah, it just seems like a complete problem from the beginning. I can't believe they would ever allow people on this shuttle. Tiles fell off just on the back of an airplane. 2,000 tiles. In the documentary, you'll see when you watch the documentary, they say they were sticking them on with the glue, and then by the morning the tiles were on the floor. So yeah, I don't believe NASA solved this problem, but basically that's all the shuttle was. It was just an aeroplane made out of aluminum, because it had to be light as well, and then just tiles just stuck on the outside with glue. It actually made me think about when I was looking into breaking the sound barrier. They had problems with the blackbirds. There was no material to seal the fuel tanks, and so it just leaked fuel because it was apparently travelling at Mach 3. But I questioned breaking the sound barrier, but that's for another video. Anyway, I've put all the pieces together, just a few snips from this documentary. You can get this documentary on YouTube. There's some interesting stuff in there. So yeah, I can't see how there's no material glue that NASA could find that could solve this problem as far as I'm concerned.
Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. However, Columbia quickly becomes a daunting challenge for NASA. Its complex makeup had engineers struggling constantly to reduce Columbia's weight and simplify construction. Especially frustrating was keeping the orbiter's ceramic tiles attached to its fuselage. More than 25,000 of them fit together to protect Columbia from the searing 3,000-degree heat of re-entry.
We were having a lot of problems with the thermal protection system of the tiles. The way we were trying to glue them on, they wouldn't stay on. And we had to come up with a way of making sure that they'd stay on. And we had some really great people that worked that, and that's why it took such a long time. I had hoped it was not going to take that long, since John and I were named as a crew, so we had a lot more time to train than what we'd both initially planned.
The requirement was to be able to handle temperatures like 2,500 degrees F that occur on the surface of the TPS, and that's 5 times what your oven is at home that you bake cookies under at max. The other problem is weight, because after all, this is an airplane, so you can't have a metallic system on it that weighs tons. It has to be extremely lightweight. And in fact, the shuttle tiles are about 90% air, and that gives the combination of being able to be temperature resistant and yet at the same time light.
Each orbiter has a unique number of protective tiles. Challenger was built with the most, 31,088, while Atlantis has the fewest, a mere 24,177.
Over in Palmdale, they had put on their first effort of putting the tiles on to protect the aluminum from the heating they were going to get on re-entry. And some of those tiles, when they put them on in the daytime, next morning the tiles were on the hangar floor. And so that was real scary that we could lose some tiles while they were on orbit and really have a problem with the heat coming back on re-entry.
Columbia had a lot of tiles missing yet, needed quite a bit of work before we could deliver it to the Cape, and we scrounged throughout the city of Lancaster for RTV, which was the material we used to glue the tiles on with.
More glue did keep the tiles in place. However, water was literally ripping them apart.
It turns out, in the instant we hit rain, the tiles almost exploded.
The tiles fabrication process was modified and the problem overcome. The tiles fabrication process was modified and the problem overcome.
The Blackbird hurtles through the frigid atmosphere, leaving a fiery tail of shock diamonds in its wake. At 2,200 miles per hour, the aircraft becomes superheated from the friction created as the air rushes by.
And indicating Mach 3.0 at this time.
When you go Mach 3, the amount of heat that the whole airframe, everything experiences all this heat, and nothing that they have at the store works. You know, there's no paint, no rubber, nothing. You know, metals, plastics, all this stuff is useless. And they just had to go through so many contortions to make every single part of the plane tolerant of these extreme temperatures.
Temperature affects everything on this airplane. The average person probably is not cognizant of that fact, but the faster you go, the hotter things get.
The Lockheed jet is 9/10 titanium, and when they build it, the CIA uses a phantom company to buy the material from the world's largest supplier, the Soviet Union. In flight, the titanium skin reaches 1,000 degrees Fahrenheit, causing it to expand by more than half a foot. This heat-induced expansion posed a real challenge to the Skunk Works team.
when in design they found that the aircraft was heated and then cooled, then the titanium skin would buckle and not return to shape. And they found by longitudinally corrugating the wing and fuselage parts of the aircraft, then the aircraft could go through the heating cycle, cool back down, and return to shape.
One of the puzzles of extreme heat was never really solved.
Sealants for the fuel tanks. They never came up with a polymer that would seal the joints in the skin panels that hold the fuel in. So the blackbirds sit on the ground and weep. That seems silly. You can look, oh, these stupid guys back in the 60s didn't know what they were doing. There's still no plastic, you know, that can get to 700F and not turn into burnt hot dog oxide.
Okay, so just two more things I wanted to add. In that documentary, the guy mentions they scrounged for RTV to stick the tiles on. So I just did a quick search. RTV is a silicone, which I guess they added to make a glue. But its heat temperature resistance is between 205 and 400 degrees Fahrenheit, which is way off the temperatures that the space shuttle would be going through. And they want you to believe that they use this to stick the tiles on. And also the other point is the expansion of the metals. NASA don't mention anywhere about the tiles expanding with. You imagine if they're saying those supersonic planes like the Concorde expanded by, like, you know, as much as a foot. So you can imagine if that metal underneath the tiles, what's going to happen to the tiles? So there's no, I can't find anywhere that talks about the tiles being able to expand with the metal. So I can't see how they ever sent the space shuttle into space. Absolutely, there's just no way. I think that it's just a complete hoax. I mean, I knew it was anyway, but this pretty much convinces me absolutely 100%. There's no way.
I think they were all very relieved because there had been some concern because we had lost some tiles initially on the orbit, and they didn't know whether we'd lost any on the bottom or not.
Around it, I couldn't believe they sent that big a mass up in the air.
People really thought this was all impossible. So what we have done and shown and demonstrated through the shuttle program is we've shown that we can take the impossible and make it possible.
While Columbia's return was spectacular, it would renew NASA engineers' worries about the shuttle's thermal protection system. During the post-landing inspection, 148 of the orbiter's tiles were found shattered, and 16 more were missing due to the effects of an overpressure wave. While that and other issues were addressed,